have to learn 3 more things. So is that it? That means we're ready for the quiz right now then. Right, 2D. Use half angle identity. Okay. So isn't 3 pi over 8 half of an angle that I know? Yeah, 3 pi over 4. Now, cotangent is simply the reciprocal of tangent, right? So, tangent x over 2, what are the, okay, you got 1 minus cosine x over sine x, or you got sine x all over 1 plus cosine x, right? So when you want to compute cotangent, which one would you rather use, A or B? You don't want to use the one with the plus or minus radical, because that's messy. You want to use this one because you got to, cotangent means you got to flip it over, right? You got to reciprocatize it. So we're going to use this one. So if tangent is this, then cotangent is the reciprocal, which is 1 plus cosine 3 pi over 4 all over sine 3 pi over 4. And then cosine of 3 pi over 4 is negative 1 over root 2. Sine of 3 pi over 4 is 1 over root 2. And then if you multiply top and bottom by root 2, you get root 2 minus 1 over 1. And then 4. Oh, it's a 4. Oh, so everybody knows how to handle the quadrant for problem number 3 then, because you can see that tomorrow. You know? I think I better go over it since it's on the video. Look, tangent x equals 3/4, and x is between pi and 3 pi over 2, which means it's in the second quadrant. So when you draw your triangle, tangent x is opposite over adjacent and at 5, and if you're known as quadrant 3, fool. Okay, but when you use the half angle identities, like how did you figure out the sign for D and E then? Because usually that's students have trouble on that every year, but not period 3. How did you figure out what quadrant, what sign to put, the plus or the minus? I just look at the bottom, and if it says minus, I use minus. That's sad! You gotta look at the quadrant of x over 2. So like when you're using the half angle identity for cosine and sine, you have to know the quadrant of these angles. How do I figure out that from this? If x is between pi and 3 pi over 2, how do I figure out what x over 2 is? Yeah, divide everything by 2. So if you divide everything by 2, you get pi over 2 is less than x over 2 is less than 3 pi over 4. And if you're between pi over 2 and 3 pi over 4, what quadrant is that in? That's in the second quadrant. So when you take the cosine of a second quadrant angle, negative. If you take the sine of a second quadrant angle, it will be positive. So that's how you figure out the signs for the half angle, for that and that. Oh, you got, most of you guys knew that already. So that's good. Guarantee that's on tomorrow's quiz. Okay, and then 4. Remember now, the plus or minus means you got to figure out which one it is. You can't. The answer is not going to have plus or minus in it. Okay, 4 D C. Thank you for putting it in order. C D E. Tangent 2x equals 3 tan x. Okay, well the only thing you can do is use the identity here, right? 2 tan x all over 1. Do we have them all memorized yet? Oh no, by tomorrow morning. Cross multiply. Minus 3 tangent cubed x. Hey, it's a cubic equation, so make one side 0. So you get 3 tangent, see how I make the first term positive? Minus tangent x equals 0. Factor out tangent. See, it just comes right out. These problems have to come out because no calculator, right? They have to factor. So setting each factor equal to 0, tan x equals 0, or plus or minus, don't forget the plus or minus what? What's the square root of 1/3? 1 over root 3, and these are all numbers you're supposed to know for tangent, right? It has to come out. My erasers need clapping. Somebody do something bad. Okay, and then was it C, D, E? D. Sine squared x minus cosine squared x equal root 3 over 2. Hey, you somebody! Actually, that's negative somebody, right? If you factor out the negative sign, you get cosine squared x minus sine squared x equal root 3 over 2. You somebody! That's cosine 2x. And then you can just put the minus on this side. And that's a number I'm supposed to know. So all you gotta do is go cosine of what angle is negative root 3 over 2. Goosh! So what's that? Come on, people. Goosh! 5 pi over 6, 7 pi over 6. But since the variable is 2x, you gotta go 2 times around. So you gotta add 2 pi to each of these. So add 12 pi over 6 to that. Add 12 pi over 6 to that. And then divide everything by 2. Don't forget to go 2 times around now. So you gotta recognize, like right here, E. Same thing except different. No, it is. It's the same thing except different. 1 minus tangent 2x. Tangent x. No, I'm serious. This problem is pretty much the same as this problem. Hey, you somebody. You somebody, yeah? That's the identity for tangent of 2x plus x or minus x? Plus x. So that's like tangent 3x equal 1. And since that's a number I'm supposed to know, this is the kind you go 3 times around. So 3x is equal to, tangent of what angle is 1? Goosh! There, for the video. Goosh! I still don't know. Pi over 4, I can do this in my sleep. You guys gotta do this when you're awake. But now you gotta go 3 times around. So add 2 pi to each of these. So 8 pi over 4. So that'll be 9 pi over 4. 13 pi over 4, that's 2 times around, and then add another 2 pi, so 17 pi over 4, 21 pi over 4. And then I'll just divide everything by 3, so there's 6 answers. I think we'll be seeing something like that. Oh, and very good, we can derive the triple and 4 angle identities. Excellent. Are you sure that's all the questions? Okay. You guys know pretty much by the we gotta finish this course by Christmas vacation, you know. Because when you come back from Christmas vacation, you only get 3 days of school, and then you have the final exam, which means we gotta review the whole semester in 3 days. How much are you gonna remember? Like, did we do this in this class or was it the other class yesterday? Because they were wondering, how hard is the semester exam going to be? Well, it's not hard. All the questions that you get will be like easier than homework problems even. Because they're not going to be test problems because it's too hard, right? The hard part of the exam though is you got to know everything. Right? From logic to polar coordinates. So, I mean, it's pretty easy, but you just got to know basic things. Just like basic information, like you don't have to know any math team secrets like that. So a problem, this is how the final exam is going to be. Which of the following is or are logically equivalent to A implies B? And then you're going to have choices, and then you have to write the choices on your answer line. Because everything is just short answer. Every problem should take only less than a minute. That's how it's designed. Okay? So here, B implies A. not A implies not B. Not B implies not A. A not A or B. A or not B. Not A and not B. A or B. A and B. Which of these are logically equivalent to A implies B? Mr. Park, can I just skip all the logic problems on the final? Yeah. You can if you want. You can just answer the ones you want. What about the first one? No, come on. What is this called? It's converse. Converse is not logically equivalent to the conditional. What about the inverse? No. What about the contrapositive? Yes, so this one is. What about that? Yes, that one is also, because remember, how do you convert an or to a conditional or vice versa? Negate the first, leave the second one alone. Oh, I forgot that. Okay, what about this? Negate the second, leave the first one alone. No! What about this? Yeah, because if you distribute the negation sign, that's the same thing as this, so yeah. And of course, these two are just ludicrous, right? So, on the answer line, you have to write C, D, F. If you don't have C, D, F, wrong, because pretty much it's just all or nothing on the final. There's like, I think there's like 75 problems, no, 80 problems. It's all or nothing and you get 20 points free though. But it's easy. It's like you don't even have to think. Okay, whatever, we have that to look forward to. But the problems are easy. It's not like complicated where you gotta do 5 minutes just to, you gotta do complicated algebra, just 1 or 2 steps. This kind is just, you just know, right? Okay, we gotta learn 3 things today. Oh, I should have wrote it on the board for the other classes to see. Okay, y equal, do you guys remember graphing this before? Last couple weeks ago, or was it last week? Last week. Remember graphing this? Remember how to graph it? Anyway, if you don't know, just plot points, right? What happens when you add a cosine and a sine function together that have the same period? You get another sine or cosine function with the same period, except the amplitude got bigger, remember? If you, no, just for that, take out your calculator right now, that's it. Too bad. Take out your graphic calculator, make sure it's in radian mode. You guys had a chance to do it. Okay, graph this, okay, but you can change the numbers if you want. Put a, I don't know, put a 2 there and a 3 there or something like that, I don't know. So if you graph a sine function and a cosine function with the same period, what happens? Oh, pretending to look busy, so she doesn't have to take out the calculator. Strike! 1! Okay, my erasers need clapping. That's what happens when you get 3 strikes, you gotta come after school and clap erasers. Guido? See, at least she's playing the game, she's hiding, right? Like she's playing pretending. You see the fingers moving, but yep. Okay, we need to make our window bigger. Like, why don't we do zoom trig, but then make x min and y min and y max bigger so you can see. Okay. How hard is it to punch in? Anyway, what do you get? Don't you just get another sine or cosine function, right? Except the amplitude got bigger. Right, this is how sound works, right? Sound are sine waves, right? When 2 people talk, does the sound get louder in the room or softer? What about when 3 people? It's louder. Yeah, so the amplitude gets bigger. Come on, you guys in physics, what's the difference between AM and FM radio? What does this stand for? Who's on the science ball team? Nobody. Who even knows what science is? Okay, there. What does AM stand for? Amplitude modulation. So what happens is they vary the amplitude of the sine and cosine thing. This is frequency modulation. So you change the frequency or the period. Okay, you guys learned that period is the reciprocal of frequency, right? How come the 10th grader said yes? You didn't even take physics yet. You guys are in physics now. So what do you do when you're listening to the radio? You press AM, FM. What do you think? Oh, FM sounds clearer. Anyway, when you add a sine and a cosine function together with the same period, what happens is you just get another sine or cosine function, except the amplitude gets bigger. Okay, so what we're going to do today is learn how to combine a sine and a cosine function together to make just one sine or cosine function. Okay? And to do that, we have to use a magic number. So, suppose we have a sine and a cosine function, a cosine x plus b sine x. Okay? The magic number is the square root of a squared plus b squared. It's not really magic, it's just if you think about it, that's what it has to be. And I'll tell you why it works, is because if you make a triangle, if these are the sides a and b, that's the square root of a squared plus b squared. Because that's like the hypotenuse of the right triangle. Okay, now, let's see how it works on a real problem. What if you had y equal root 3 cosine x, I hope this is not the same as the homework, but that's okay, even if it is, plus sine x. Write this as a single sine or cosine function. In fact, I'll do both. Let's do, which one you want to do first, cosine or sine? Okay, cosine. Write this as a cosine function only. Okay, so the first thing you got to do is you got to figure out what the magic number is. What is the magic number? 2. It's the square root of that squared plus that squared. That's a 1, yeah? 3 plus 1 is 4. The square root of 4 is 2. So what do you do with the magic number? You factor it out. So whatever the magic number is, you just factor it out. Okay, what's going to be left? Root 3 over 2 cosine x plus 1/2 sine x. Right? Because if you distribute the 2 in, don't you get the original problem? Or we're going to have problems like the other factoring thing again. Hey, Mr. Park, look, root 3 over 2 and 1/2. These are numbers I know. Yeah, that's why it's magic. Except it's not magic. Okay, now you want to write this as a cosine function, right? So you got to know your identity. The cosine of gorilla plus banana is cosine, cosine, sine, sine, right? So we want to change this into some cosine. So you just think, cosine of what angle will give me root 3 over 2? Pi over 6, that's right. Ah! And then over here, we want to change this to sine. Sine of what angle is 1/2? Pi over 6. And of course, that angle got to be the same as that angle. And then, hey, you somebody. Look, cosine, cosine, sine, sine. You somebody. What is it? That's cosine of pi over 6 minus x. And there you go. You wrote it as a single cosine function. But you got to simplify it. So you can simplify this to cosine of, can I just switch to x minus pi over 6 like that? Is a minus b the same thing as b minus a? You guys have to think about that. Is 2 minus 3 the same as 3 minus 2? Wait, let me get my calculator. -1, 1. No! But how come you're doing that, Mr. Park? Because cosine is an even function. Cosine of negative x equals cosine of x. So you can do that. With cosine, you can. And why do you do this? Why do you put the variable first? Because you still don't know how to graph it when it's not first. How many times have I given you this here? Graph f of 2 minus x or 1 minus x. Some of you still don't know the correct order, yeah? Even though I said sunrise. You guys still can't do it. So that's why we just put the variable first, and now you know you just shifted pi over 6 to the right, yeah? So if you add these two functions together, you just get another cosine function. The amplitude is 2 now, which got bigger, and then you just shift the graph pi over 6 to the right. Oh yeah, but Mr. Berg, what if I want to write it as a sine function? Okay, well let's do that then. So once you hit this step right here, okay, we go over here now. How do you write this as a sine function? Well, you got to know your identity for sine then. What's the identity? Sine, cosine, cosine, sine, right? Okay, so we have 2. Change this to sine. Sine of what angle is going to give me √3 over 2? Pi over 3. So again, if you don't know your values, you're done for, right? And cosine of what angle equals the 1/2? Pi over 3. And then you write that on your paper and go, hey, do somebody. You somebody. Look, sine, cosine plus cosine, sine. That's the identity for sine of pi over 3 plus x. And can I switch the x and the pi over 3 like that? Yes, because a plus b equals b plus a. That's called the commutative property of addition. So if you add these two together, you just get another sine graph, except the amplitude got bigger, it's now 2, and then you just shifted pi over 3 to the left. And so anytime you have a sum of a sine and a cosine function with the same period, you can always mush it together into just one sine or cosine function using the magic number. You're going to be doing this at least twice on the test on Friday. You won't be doing this on tomorrow's quiz because we're learning it today, right? Okay, so that's one thing, the magic number. You guys understand what it's used for? When you add a sine and a cosine function together and you want to just mush it into one sine or cosine function. Okay, next, products to sums and sums to products. Products to sums, sums to products. Did you guys cover this last year when you studied trig? I didn't even know what that is. Mr. Rubash told me he mentioned it to you guys, that's why. Here, true or false, this is your Algebra 2 book. Okay, I'm going to go to the trig section. Okay, sums to products, products to sums. They have a whole, there's like 7 identities here. Okay, where are they? Oh, there they are. Okay, I'm going to write it over here so all the other classes can see. This is right out of your book. Do these look familiar? Sine alpha sine beta equals 1/2 quantity cosine alpha minus beta minus cosine alpha plus beta. Cosine alpha cosine beta is equal to 1/2 cosine alpha minus beta plus does this even look vaguely familiar? Like Mr. Rubash gave you a bonus quiz? Did he even mention it? He's in trouble. Sine alpha cosine beta is equal to 1/2 sine of alpha plus beta plus sine alpha minus beta. See, these are the products to sums identity. See how it's a product, they're multiplied together? And now they're sums. See how there's plus or minus sign? You change the product into a sum. And now the other way, what about sums to products? Okay, here they are. There's 4 identities here. Sine alpha plus sine beta. See how it's a sum? That's equal to 2 sine alpha plus beta over 2 cosine alpha. Don't write these down, okay? I'm just showing this to you because it was in your book last year. That doesn't mean anything. 2 sine, obviously, over 2 cosine alpha plus beta over 2. Because otherwise you think I'm lying this way. Cosine beta equals 2 alpha plus beta over 2 cosine alpha minus beta over 2. One more. Cosine alpha minus cosine beta equals, when I was in high school, our teacher made us memorize all of these. See how you change a sum into a product now? Why do we have to do that? Okay, now who wants to memorize those 7 identities? You guys can barely even memorize the basic ones, right? No, we're not going to memorize them. I'm going to teach you, just using common sense, how to just do it. Okay, which one do we want to do first? Let's do sums to products. I like sums to products. That's easier, that's why. Okay, so suppose you have cosine 7x plus cosine 3x. Isn't this a sum? Because there's a plus sign. What if I say to change this to a product? Well, you can memorize the identity over there. Hey, this looks like the 6th one over there. And then just do it, okay? Or you can just use common sense. Okay, now, in order to use common sense, okay, look at the argument, 7x and 3x. What's the average of 7x and 3x? We cannot find the average of two things. You add it and divide by 2. What's the average of 7x and 3x? 5x. So what you're going to do is rewrite this using the average. So we go 5x plus 2x. And 3x, what do you think? 5x minus 2x. Now, those of you with foresight, can you see what's going to happen in the next step? What's foresight? Okay, use the identity. Cosine of gorilla plus banana. Cosine gorilla, cosine banana, plus or minus? Minus sine gorilla, sine banana. Okay, this one over here. Cosine gorilla, cosine banana, plus sine gorilla, sine banana. What happens in the next step? These two cancel out. What's left? You have iguana plus iguana. That's 2 iguana. And there you go. I changed the sum into a product. See, they were added, now they're multiplied. Why do we have to know that, Mr. Park? Because on the test, or when you're solving equations, how would you solve this equation? Well, this is just one application of it. How do you solve this? What if I give you this? Solve this equation. Can't do it now, right? But if you change it into a product, now can you solve this equation? Yeah, because since they're multiplied together, you just set this equal to 0 and that equal to 0 and then finish, right? Except you got to go 5 times around and 2 times around, right? So that's why we changed the sum into a product. Well, that's one of the reasons. Okay, now the other direction. The other direction takes a little more ingenuity. Or in your case, ingenuity. In fact, let's do the same problem right here. Let's just go back. 2 cosine 5x, cosine 2x. So basically, we're just going to go backwards. How do I change a product into a sum? Now, it's easier if you have a 2 here, but you really don't need the 2 there. But if you have a 2, because the first step is to break it up into 2 pieces. If you have 2 iguanas, how do you divide it into 2? 1 iguana, leave a space, and 1 iguana. We're just basically going backwards. Right? So what doesn't matter how much you have here. If you have 5 here, then you go 2.5 iguana and 2.5 iguana. Just divide it into 2 equal ones. Okay, now this is where you got to think. What do I have to add right here to make an identity? Like right now I have cosine, cosine. What do I have to add right there to make an identity? Sine, sine, right? So you add sine 5x, sine 2x. But of course, if you add that over there, you got to subtract it over here, right? To keep it the same as the original. Right? It's kind of like completing the square, except not. So you look at the first 2 terms. Hey, you somebody! Cosine, cosine, sine, sine. That's the identity for cosine 5x minus 2x. And then if you look at the 3rd and 4th terms, hey, you somebody! Hey, how's that? I don't remember your name. Your 5x plus 2x. So now you just simplify. 5x minus 2x is 3x, and 5x plus 2x is 7x. And boom, there, we changed the product into a sum. So if you don't like what I'm teaching you now, memorize those 7 identities there. Then you can do them, because these are all on the test. Not going to be on tomorrow's quiz, but they're going to be on the test. It's easy. It's a technique, right? You just practice them a couple times, you got it. Why do we have to do this? Because those of you going on to BC Calculus, this is the most important one for BC Calculus. Because next year, you're going to integrate this. You guys right now don't know what the integral is, but you're going to do it. But you can't. There's no way you can do that. But if you change it into a sum, now easy. Just believe me, okay? AB, we don't even do anything close to this. You know why? Because we're AB. We're a step below. BC Calculus, though, that's creme de la creme. You gotta know stuff. Okay, so those are the 3 things you need to know first. So tonight's homework, basically, this is a practice test. The next 2 worksheets are practice tests, and these 3 problems will be on it. Okay, we're done. If the bell rings in, 7 minutes. Okay, so tomorrow, don't expect to do a lot of problems on the board because we got the speed quiz and the regular quiz. But then it's basic schedule.